pinout for connectors. So first keyboard babble link. So if you're really lucky, they already did one for you. Then you're great. But it doesn't necessarily tell you everything you need to know about it. But
who are they?
One guy. I managed to email him once, and he responded. But he's a really busy person. But he started all this way before GeekHack existed. But this is a really cool website if you ever want to look at this stuff. I'll show you another page later. But he actually did 8 connectors and tells you what they are. This is really useful because now, I mean, he doesn't know what those do. This means you can turn on the keyboard. That's the big first step. You can put power to your keyboard. Because you don't, when you turn it on for the first time, you don't know if it's fried or not. But, yeah, there are a million connectors. Hint about connectors. Unless you're dealing with this one, you can usually get them for free. You don't even have to go to DigiKey. All you go is you go to some connector manufacturer saying, I'm an engineer, I am working on this product thing, send me from some free samples. They won't even charge you shipping. It's great. Just don't sound like you're just want free stuff. Just say, I'm building a product. And just
order like 20.
No, like 2.
You just want 2, 1, 2, because that's all you need.
I've had a European vendor who made a TrackPoint-like thing. I went and requested 2 samples on a Monday evening at 4. Wednesday morning at 7:30 in the morning, FedEx was knocking on my door. They had overnighted them.
Nice.
Free. But sometimes it gets really complicated when the connector is really expensive. Then because when you say you're engineering something, they usually want to oh, how's your project going? And so you guys sort of disconnect them. But yeah. So just a hint, because rather than splicing a cable, just use a connector. It makes your life easier. But, yeah. Attempt to power on the keyboard. The keyboard might be working. You don't know. If the keyboard has LED and one of those keyboards does have an LED, try to press it. If it turned on, you were successful. That is basically, at this stage, the only thing that you could tell you that you have successfully powered on the keyboard. Now, some things that can tell you that you did not successfully turn on the keyboard is that, I'll show you later at the power supply, but if it keeps sucking out a lot of current, because there's 2 parts of power. There's voltage, which is the difference in electrons, and then there's current, which is how many electrons are flowing. It's like the flow of water. How fast is it flowing? If there's a lot flowing through, then it's likely not working. Unless you know your keyboard takes as much power as a generator, or basically a lot more. So, yeah. I'll give an example. The main reason why I brought these 2 things instead of just using USB power. Both those keyboards are 5 volts, but using this, I can show you how you turn on nicely without destroying things. So, now that you turn it on, you got to probe, basically, because you've done your pinout now, you know where VCC and ground are. You have all these other pins that do something, you don't know what they do. So now you take your oscilloscope, and you have to probe them. Press a key, see if it does something. If it doesn't, add a pull-up resistor or pull-down resistor. 100 k ohms is usually a pretty good rule of thumb. Don't use different ones. Just that you'll get weird stuff if you just want to use the same one. Sometimes you get weird voltages and things, but yeah. Sometimes the pin you're trying to deal with isn't really an output pin; it's an input pin. So you can, if you're really good at data sheets and tracing your pins and PCBs, you can figure out if it's an input pin or not. But most of them are usually output pins, but sometimes it'll be like an interrupt pin or a reset pin, something along the lines of those. So you can usually go back to the microcontroller data sheet and figure out, this doesn't look like all the other pins around, it's probably an input. You don't know what input is, but you can guess. And for most purposes, it's not important. for these keyboards, you can get those working later. Like it turns some LEDs on or something. I had one that you could configure the beeper. It was so fun. I could tell it to beep. So that Burroughs keyboard, some of you tried it. You liked it, but basically I could configure 30 different types of beeps, and one of them was a clicking noise. It was cool. This is just all built into the keyboard. It was great. So fun things to do. Sometimes I give up. Yeah, that's basically what it comes down to. It's either not worth your time or like there's something could be fried on the keyboard.
In these cases, if you have a component or chip that is bad, is it possible to
figure it out?
No, I was gonna say replace the. And this would be a complete teardown, but replace the board with.
Oh yeah, like if you want to just replace the board, that's totally doable. But that usually requires a different sort of expertise and different amount of time sort of thing. So like if you're down to do a full controller replacement, that will get you the basically best keyboard, the fastest response time, and all those things. But there's another part of that. Like if you took a really old keyboard, that a lot of my keyboards are the only one I know of that's its kind. I do not want to destroy this keyboard, so I will try really hard to choose the protocol instead. And that's the big thing. Or sometimes it uses a weird sensing technology, I have an inductive sense keyboard, not a capacitive sense, inductive, or an optical keyboard that has weird matrix things.
I guess in those cases, if you were going to do that, would you use an Arduino, or would it not completely not necessarily just map it to or just solder it to
I'd use like something like Arduino. I use teensy stuff. I now have like the Infinity keyboard that I produce. I have my own basically microcontroller that I use now. But like a teensy is way powerful about. There's a lot of software available for it. So it's basically there's no programming work you have to really do. You can focus on actually making the hard part. But yeah, if you can't get stuck, some chips are bad. The components are bad. Bad components is a big part. External clock. Some keyboards I have require the computer to give it its clock. And sometimes you can figure this out as another input pin. So basically what you do is you go 0, 1, 0, 1, you just keep putting a value and you sort of guess. Sometimes like USB, there's this initialization routine that has to come on, and that's basically impossible. I actually took a chip, I ROM dumped it, I actually disassembled it, tried to figure out what was going on, and I spent a week. I was like, Haas is better at that than I am, but he figured out the cache saver stuff. But if the code was written really awfully, or is compiled awfully, yeah, unless you really want it and you know it's not going to suck, it's not worth it for you. The easiest thing to do is find the original computer, plug it in, and take a logic analyzer, just probe it, because then you know what it's doing. That's really easy. But don't always have the original computer. And then know if it's input or output. That's pretty important. If there are a lot of pins, it's probably parallel. It's pretty easy. You can typically pick up a keyboard with a big connector. It's probably parallel, or they're scanning it per key individually. So look at that. This is that Selectric I brought. Some of you got to see it. It's a mag type where it's every key. I could actually compare it to a computer. But there are so many freaking pins. It would take me longer to actually figure out what all these pins do and apply the proper voltages. It's like I really want to type on it, but not that much. Yeah. I don't have that kind of time. Now once you figured out what to do, logic analyzer time. So you put this logic analyzer, which what it does is it records the changes in 1 and 0 over time. So you basically set to record. It will record what's going on during time, and you press keys. You want something to happen. And then for every key that you get an event for, you try to isolate what that event was. Now, you'll get these pulses, and you have to logically convert those pulses into basically numbers or an event. Like a parallel bus, you convert each of those pins at the same time. That would make a number. So, yeah, it's this part is to me the fun part. Actually, you finally got something. Now, what does it mean? What's the difference between a press and release? Is there a press and release? And I'll show this part off. It's serial. There's a clock rate. I was talking about this clock rate that you might have this clock signal. Yep, there's that. Fortunately, if there's just serial data, good logic analyzer will actually give you an estimate of what it is. It can analyze this protocol and figure it out for you. And then when you make your converter, you say something close to that. You don't have to be exact. More keyboard babble. This is like the really cool part. So you have diagrams like this, and it looks a little tricky to understand. Let's try to find it. An easy one. Here's an easy one. So here's a Mac keyboard protocol. So here's our clock. So it's going up and down, and basically here, when the clock is up, this is when you can read. So you're looking for this down, and on the up, you know the bit's ready. So you can read it 0. Again, and as you next bit, next bit, next bit. Here it's really hard to read, but it says there's 300 microseconds of time here. And so this is the sort of thing you have to worry about. So if your microcontroller has hardware built in to deal with this timing, then you can deal with it. But if you don't have hardware and you have to basically in your program say, is it 1, is it 0, is it 1, you have to deal with these delays, and it gets pretty complicated. And if you miss one, then you can get hosed, and you have to figure out the error cases. It becomes a programmer's nightmare because you have race conditions. But there's all sorts of different protocols. Here's like 159 bits. Yeah, there are all sorts of weird ones. Here's AT PS2. So this one is weird. PS2 is a lot more complicated, and fortunately you don't have to deal with it. But basically there is input and output protocol, and they use the same wires. So yeah, there's controlling of who owns the bus or who's going to talk next. You have to start dealing with that. So not just one direction communication. But most.
So that's a multi-device bus. You can have like a bunch of PS2 stuff on the same.
No, it's just host and device basically. If you want that, you got like I2C or actually USB.
Yeah.
But yeah, PS2 is not really that nice to deal with. It's just it doesn't suck, so you can actually make a keyboard that's reasonable with it. This website is great. So if one of the keyboards you have is actually here, it's actually a good first keyboard because you can start with something I know this stuff is right, and so then I can take my logic out and say, okay, that really what it is, and so I can program to that spec.
These are like the learning keyboards, right?
Yeah. So like if you can find them. This guy basically started before I was even into this stuff, where keyboards were existed. Yeah. So, but he has all sorts of weird keyboards.
Have you thought about collaborating with him at all?
I've only managed to have like one email with him, and like ever. I said what I did, but
You're not worthy!
basically. But he's really cool, and he keeps all this stuff online, and he does a really good job of documenting it. Like, I wish I had the
Dude's probably right down the street.
yeah,
Probably a nerd from, whatever.
yeah. But yeah, he has like the rigor to actually work this out. I can't be asked to do this stuff. I mean, it looks so nice. yeah, once you've done that, it's time to code. And coding, depending if it's really sucky and you're trying to do these weird cases, it takes a while. But if it's really easy, it takes me like a couple hours, afternoon. I can chug out a keyboard converter. Once you have all like you dealt with the USB stuff, you dealt with how your key map as well work. The way I structure my stuff is that I just dealt with that once. It's like, okay, I just define a keyboard. I just deal with the protocol, and that's all I do. Yeah. That's about it. Programming hints. I'm not going to cover programming because I'm talking too much. Use microcontroller hardware. That is my biggest hint. If you can do it, use a UART. Sometimes you can't. The hardware for the UART isn't compatible with what you're trying to do. But sometimes you can massage how it works in order to make it work. And this gets rid of that whole like, I have to wait 30 microseconds, then 7 microseconds, then do this thing. So it avoids having to deal with all that, which is something you really don't want to deal with on something like an Arduino. The Arduino just can't deal with that. Especially because now you have to deal with this USB thing that can happen at any time. Because you have this, it's not just a single threaded program that you have one thing happening at the X. If your USB, your computer says LED turned on, it's gonna like take over the processor and it's gonna delay you for 100 microseconds. So you have to sort of think about those things. So if you can use hardware, that simplifies things. You can just make an interrupt for it if you know what that means. But sometimes you just can't, and so you get down and dirty with GKO. Yeah, interrupts. They can make your life hell when dealing with this stuff. There's a lot of design decisions in terms of my controller code, which were made to make sure I can be very strict with how my timing works. Because there are some protocols where I have to be very, once I read from the UART, I have to stop it, and I have to basically read those pins constantly in order to get protocol. I have to delay the USB to do anything. I have basically this little window where I can send my USB stuff. So, this more complicated problems to think about. The keyboard will work, it's just sometimes it won't work. And yeah, that's the really crap place. Yeah, good luck. So that was the presentation. Woo!